on the other link and we are able to start from the same section, right? So basically we are jumping some streaming URLs. So that's what we are doing over here, right? Okay, check this out. So notice this. Now let's put everything together. So in the starting, we were talking about, okay, that convolutions are basically, you're moving a filter around which the layers are learning on their own on the input image. And the output is basically a feature map. And the feature map is the input for the next layer called as a pooling layer. And based on this feature map, we're extracting more, we're aggregating the input learned. We are basically aggregating the features learned in the CNN layer. We are further aggregating it over here, and this is acting like an input for the next layer. Again, more convolutional operations are going on, and filters are being learned over here, and then more pooling, and then convolutionals and pure pooling. The same type of pattern repeats, right? And then finally, we have a fully connected network. A fully connected layer will be there, which will finally dump the output into a softmax function and so on and so forth. So this is basically how a vanilla convolutional neural network will look like, with pooling layers, feature maps. If it is classification, then softmax. If it is regression, then some linear function will be there, activation function will be there, and feature extraction will be done as such. Okay, so now let's talk about how to make it. We have done 1 hour of you can say we have talked about on this for last 1 hour. Let's talk about how to make it on Azure platform, right? So I'm just giving a little introduction of Azure platform in terms of what type of AI solutions are there, and then I'll show it to you, and then I'll give you one link as well. And I have created one tutorial yesterday, and using the tutorial, you will be able to follow what I'm doing over here, right? So we can practically do it. We just need Azure subscription. So if in case you don't have it, we can go for a free subscription of Azure like that, right? So check this out. Before I jump into that part, a little overview of Azure platform. So Microsoft Azure, what does it provide you, and so on and so forth. So there are 3 type of AI, or you can say there are 3 type of solutions I can create on Azure. First is called as, of 3 sections are there basically. First is called as pre-built AI solutions. Second is called as conversational AI. Third is custom AI. So pre-built AI are for developers, where these are vertical products are there, and the vertical products can be integrated into any industry as such. Speech, let's say in language translation, natural language processing. We even have various type of OCR solutions are there already available. We can use those solutions and we can integrate with our solution with our product, and our product becomes AI enabled. Second type of AI services on Azure are called as they fall in the section of conversational AI. Conversational AI is where we create chatbots. Chatbots will be talking to the customers over various channels. Channels over here right now means Facebook, maybe email channel is there, website, you have integrated the chatbot with the website. So various channels can be there where my customers are present. So I want them to talk to my chatbot, and that's how I can have AI solutions on Azure. Third type of thing can be custom AI. Custom AI is basically what we are talking about right now, that we will create our own AI solutions, we will create our own deep learning solutions, we will create our own CNN model, and so on and so forth. So any data scientist will be able to create their own custom AI solutions. Now, what else do they provide? Now, if we talk about data, we have to keep it somewhere, right? And practically your databases might be distributed in nature. So we have on the left side, so those who are not working in Azure platform, it might not make sense. So I'll just give you a one-liner introduction for everything over here. And rest, you can look for the word for in any of your favorite search engine. You can look for like what exactly that service is. So Cosmos database is a place where you can keep your data. It's a distributed database. It's a multimodal distributed database. It is there you can create various endpoints throughout the globe. It can be distributed like that. I can also have MySQL, Postgres, and Azure SQL solutions can be there where you can keep your structured data. Data lake is Hadoop file system. Data lake is where there is no upper limit. You can keep as much of data as possible, and whichever big data tool is reading from data lake will be processing, will be doing your deep learning, will be doing various parts as such. Now, how do we train our solutions? We, for the training the solution, if you are working on a big amount of data. So today I thought that I will give you a lab which is very complicated. I'll give you a tutorial which is very complicated. But the problem with deep learning is if I give you something complicated, we cannot finish that in the session. It will go for next. So I trained one model, I think I started a day before yesterday. I just kept it for training purpose on Azure on a GPU machine, and it trained for maybe 17-18 hours. So I didn't took a cluster as such. I just had one GPU machine over there having 56 GB of RAM and one GPU as such. You can create a cluster, you can do distributed training on cloud platform, but that is something which you can do in production. Personally, if you're paying for the account, you don't create a cluster as such. So I was thinking of giving that as a hands-on, which will train for a longer time. However, I thought that we have to finish it practically in the session. So I have a sort of, I took a smaller data set, a toy data set for you to work with, but the same logic you can apply into a bigger data set. I'll give you provide you the links for it. Okay, so how do I train my solutions? I basically can do my analytics on Spark, right? Apache Spark. So in Azure, we can do that. We have a thing called as a DSVM. DSVM is basically a virtual machine, which is having, what is a virtual machine? Virtual machine is basically your laptop instance in any of the cloud platform. In AWS, we call them EC2 instances. Here, we call them virtual machines. So if a data scientist want to have a workstation in the cloud where he can perform data science, he can create a DSVM, which will come pre-installed with everything required. We can have GPU-based solutions where TensorFlow GPU will be default installed, Keras will be installed, Anaconda will be there, our solutions will be there, and everything which is required will be there in one place. So that's a workstation in the cloud called as DSVM, Data Science Virtual Machine. We also have a thing called as Databricks. Databricks is also one more, it's a very, it's a third-party company, but they have a tie-up with Azure, and they offer Spark services in Azure. Zero management Spark solution is called as Databricks. AKS is Kubernetes, Azure Kubernetes services, where you might be hosting your models after the training as such, and for scoring purpose, right, in production. IoT Edge is basically I want to deploy something in the edge device itself. So what do I use to do that? We can use Visual Studio Code. There is a graphic designer. Workspace is something which we are using today. And we are using Jupyter Notebook for the tutorial as such. And deep learning frameworks, everything is supported. Keras, TensorFlow, PyTorch, Chainer, Cognitive Toolkit, and so on and so forth. Right, everything will be there in Azure platform. So what am I talking about? Let me quickly explain that in a different example altogether, and then I'll just show it to you, right? And then we'll start working on it. Check this out. So okay, check this out. So let's bring a data scientist, right? Let me use the whiteboard a little more. I think you guys might be little looking at all the slides. It's really right. So check this out. So I have, let's say there is a data scientist over here, or you, basically that's me or you or anyone who wants to work with data science on our cloud platform. So what do we need basically? We need some sort of editor with which we can work. So whichever editor comes to your mind, VS Code or PyCharm or any Jupyter Notebook. So let's say that's a Jupyter Notebook this person opened in his laptop, right? That's the laptop. What else can I do? Do I really have to use my laptop for all this? Can't I have a cloud hosted Jupyter Notebook? Yes, we can have that as well, right? So right now, let's start from here, that there is a Jupyter Notebook in the laptop altogether. So these are various cells in the notebook. Now your data, you're working on a big amount of data. So where will you keep the data? In your laptop, you can keep a sample of it, right? However, and your laptop will not be, if you use the laptop for the training purpose, it doesn't have the compute, it doesn't have the CPU over there to be able to, or GPU over there to be able to do a deep learning experiment as such. So we need some sort of cloud hosted solutions. So we were just talking about this. So the first concept you will see, I'll just cover a little bit of Azure machine learning, then I'll tell you how are we combining CNN with that. So we will see a concept called as data store, right? There will be a thing called as data store. Data store is basically where I'm keeping my data. Maybe it's an object store, maybe it's a Hadoop file system, it's structured table, it's MySQL, or maybe it's a file share. So files are lying over there. So data store is something we will look at where data is existing. Then we have one more construct which is created on top of data store called as data sets, like that. So these data sets are like tabular data sets or file data sets. Tabular data set is something which we will be loading in a pandas data frame. File data set is something which we will be working. If you're working with images, your images will be in a file data set, right? So now what I want, I am over here on premises, right? So I can say that connect to cloud. So this is where I'm doing the connection, and this is where I say connect to Azure Machine Learning, and I provide the authentication, authorization, everything works, and I connect it to, when I execute this cell in Jupyter Notebook, basically I connect to Azure Machine Learning Service. In the second step, I'm saying that, okay, go and pick up my data from that data store, right? So you can say which data store your data is lying into. So you are running the pipeline, you are running the notebook over here, and everything is happening in the cloud for you. So you say, okay, pick my data from this location. There's a huge, so storage account can be as big as 500 terabytes, right? So you're saying, go and pick up my data from that location. So basically data will come from there. Now you're saying that I create me a compute cluster. So you can say, okay, I want a compute cluster. So you basically have to write a couple of more line of code, but in the end, it will create you a cluster of your choice. So cluster will be in terms of Spark cluster, Databricks cluster, local as well. Maybe you're using some sort of high performance computing where you're doing parallel processing, or you're saying make me a VM with GPU and run my solution over there. So compute, when you say a compute cluster, basically it creates a compute target in cloud. So data is coming from here, right? It can directly be as such, or maybe through these type of construct on top of data. And this is where your machine learning solution will be training over there. So the training will happen over here somewhere, right? But when we train, we have to provide a training script as such. So you, once you have done the testing on your solution, what you will do, you will simply create a training script here. So this is where I'm saying that, okay, this is my train.py. This is my training file. I have tested it out. It's totally correct. And now I say run that. So when I say run, this training file is basically uploaded into the cluster over there. And that's where the job is submitted and the training starts on that compute cluster. And the data is coming from data locations, from data stores. And once you have finished it, right, what you can do, you can definitely download your model, and you can have that output model or downloaded model here. However, what I can also do, just give me 1 second. Right. Some questions are in the chat window. Let me quickly take those questions. I actually was not noticing the live chat as such. I just noticed it. This is Azure, where we're talking about Azure. Which DSVM is better for deep learning, Linux VM or Windows? I feel Linux VM might be more stable. Both of them are as good as they can be. As such, there is no difference between them in that context. What to use if you use Docker images for models? Check this out. So we are just coming to that part. So over here, what I can do, I can download my model, right? So basically, I'm saying, let's download. We can download like a pickle file. We can have H5 file format. So today in the tutorial, you are doing H5 file format. You are basically downloading the model, right? However, where will you keep it? So you might not be the only person who's doing machine learning on Azure platform. There are more team members who are working on various things, right? So we want a repository where we can do model management. So that is totally available. There is a thing called as literally model repository. It doesn't have any other name as such. So you will see that there is a place where I can register my trained models. So whatever you are running in the compute can be saved over here for model management. version 1, version 2, you did 4 runs. So what was the output of run number 1, 2, 3, 4, like that? You are doing some sort of hyperparameter tuning. Now you are running, you have alpha values as such. So you have 10 alpha values. You want to find all the models and the best run as well. So everything can be managed in the cloud. You don't have to keep anything in your laptop as such. Now, after that, so the problem which happens with models like this is that when we try to deploy them in production, dependencies are not there as such, or they might be problems because it requires some particular type of dependency which needs to be taken care of. Otherwise, we'll get some new errors. So that's where the Docker comes into picture. So as part of this, what you can say, you can literally say, so this is register my model. So if I say register my model, basically model is here in the model registry, right? After that, if I say, okay, I now want a sort of image registry. So what is an image registry? Image registry is what I'm talking over here as ACR. So what will happen there? Now, if I just run this piece of code, this model will be picked up, right? You have to provide the environment file. Environment file is basically having, you can say, what is required for this model to run in future. So using this environment file, one Docker image will be created. Your model will come from there. That's M4. Whatever dependencies are required will be installed in this image. We also need one more type of file as such called as a score file. So score file is basically afterwards when we deploy this, this file is what loads this model and do the scoring in the end. So a Docker image will be created for you. If you just run a couple of pieces of code over here, and automatically for a data scientist, the Docker image will be created. And that also will be stored in Azure Cloud over here in a location called as ACR, Azure Container Registry. So this container registry are basically Docker images where models are already there. Can we use secure VMs also? I hope you're talking about secure VMs in the sense that we are we have type of VMs in which when the processing is going on, you cannot access the, you can say, the CPU section. It's totally I think I skipped the word which was there. It was TPM maybe, which is basically a secure section in the CPU where the data is being executed. I need to check whether you can use secure VMs along over here, but I can do a training with my encrypted data. So data can be encrypted. We can bring it, decrypt it, train it, and put the data back, right? So entire encryption can be possible on the data, and that is something which recently also came out. Now, once I have this model, I can publish this model into any of the location which of my choice. Maybe it's a Kubernetes cluster. Maybe it's another type of cluster over here. ACI we call that. ACI is basically where you run your Docker containers. Azure Function is serverless. As a web app is like a website, and you can also deploy solutions on IoT edge. So what Azure Machine Learning provides is a pipeline where for a data scientist, he can use his laptop, any editor of his choice. He can also create a thing in Azure Cloud over here. So let's say I create a small size of VM, and in this virtual machine, I install Jupyter Notebook. So whatever you are doing in your laptop, that can also be done in this notebook section in Azure Machine Learning Service. For that, a dedicated VM is created, and in this VM, Jupyter Notebook is installed basically, and you get access of it. One more thing I can do is I can use notebooks.azure.com. So today we are using notebooks.azure.com. Why? Because it's free of cost. So notebooks.azure.com, and we'll have a Python notebook, Jupyter notebook over there. And this notebook will be connecting to the Azure Machine Learning Service, which you will create, and step-by-step processes will be done on it. So what is Azure Machine Learning? Custom AI solution. It's basically this pipeline which lets you keep data in various locations, structured, unstructured, train it on a compute cluster, do model management, create Docker images with a couple of lines of code, deploy your solutions, right? Operationalize the models. Okay, so let's quickly go and check this, and then we'll start doing some sort of hands-on as such. So I have my Azure portal here, right? So this is the Azure portal, and let me just see if I'm still signed in. Okay, that's great. So basically, I just do it like that. So we just say Azure Machine Learning Service. Whatever I'm doing, you guys also can do it. I have the entire thing documented over here in this link. I'm putting it in the chat window. You can, I hope someone can just forward it to the live chat section as such. Right. So what's the difference between Azure, Kaggle, Colab, Binder? Azure is a public cloud. Azure is a cloud platform, right? Like private cloud, public cloud, where we have infrastructure service, software service, and so on and so forth. Kaggle is a platform where we are doing data science challenges, right? But they don't let you deploy things in production. They don't give you, you cannot create serverless solutions and so on and so forth. So instead of having a private cloud, I can do anything in a cloud platform like Amazon Web Services, Google Cloud Platform, Azure, Oracle Cloud, and so on and so forth. Colab is basically what I have over here as notebooks. You see this Azure notebooks, that's basically what Colab also provide. So let me show this. This is Azure platform. Let me just practically show it to you. Notice this. So I have the Azure subscription over here, and this link, hopefully you guys already got it. So this step-by-step, whatever you are doing over here, I'll just show it to you, and then we can start talking about it. And this is from where you can download the notebook and so on and so forth. And the notebook is available actually on this section. I'll show you the notebook right now, but you can run it from here, and I'll explain what we are doing. Then we can start working with it. And these are some of other things, some links I found, very interesting links, and I just have put them in one place. You can go through that. Okay. So that's Microsoft Azure, and we are creating Azure Machine Learning Service. So I'm just searching for it like that. Just say machine learning, maybe. Yeah, that's the one, right? So you can also create it like that. You guys will be using this one, and over here, Azure Machine Learning, and create it, right? And just basically fill up this form. You cannot break it as such. So whatever you are filling over here, it's actually in this step. So you can go to Azure Machine Learning. You can click on basically on the Azure services, and then you can search for machine learning on the left-hand section on the top. Click on this create option. So the tutorial is there for you to navigate and find how to create it, right? So go on this section over here, and right. So hey, hi Ashish, how are you? So check this out now, and can we have the link? Hang in for a second. Give me a second. Yeah, I have shared the link to Usha. She will be sharing it very soon, right? I already did that. I hope everything is fine in Pune, right? Work from home now. Okay, so guys, the link is there in the chat window. Hopefully it will open it up and everything will be over there. So this is like a step-by-step guide how to actually reach the machine learning service. And once you reach the machine learning services, where you have to open the notebook, and the next steps will be there inside the notebook. So let me execute it for you first, and then you guys can start doing it, and I can help you on the way. Let me execute it first, right? Let me show you what we are doing in this step. So we basically come to this machine learning workspace. Give any name of your choice. You can give any. So right now it's not relevant what's a resource group. I'm just making a, let's say this is Shivam's resource group, like that. Already exists. So Shivam's resource group 2, like this. Workspace name of your choice. Uh, you can have the choice. Anything you can give any word and name as such. There should not be any error. Just for example, I can say Shivam's AML service, right? Like that. So you will be able to create it. Location, I have given the location that you can keep the location to be East US or Southeast Asia. These are basically Microsoft data centers are there, and that's where we are deploying the machine learning service, right? So the locations, you can keep it like this. What type of version do I want to make? We have two versions. We have basic, we have enterprise. Right now it's not that relevant to differentiate between basic and enterprise, but we are creating the bigger one, enterprise as such, and just create it. It will take a couple of minutes for it to create, and then finally, how will you find it, right? Sometimes we are not able to find the resources. So if you notice on the left hand side, we have this hamburger icon is there on the extreme left corner, top place. If I click on it, you saw me create this resource group, right? So don't get confused. You can click on all resources. You will see your created resources in one place here in all resources, right? So if you're not able to find it, just click it over here, click on all resources. You will see machine learning service, which looks like that over there, right? And if I click on let's say resource groups, you will see the same file is there as well over here. So I have not put actually how will you navigate that thing. I just realized that I have not put it in the tutorial. So if you are new to Azure, basically click on this icon, all resources, and we are using this one, right? Okay, so till here, that's how we navigate to a machine learning service instance in Azure. That's the first part there. Then what else do we have? We have experiments. We have pipeline, is what I was showing as the entire diagram is a pipeline. Compute is what we were talking over here as compute target, this section. Models are what we're talking about here as that our registered model will be there. That's where you will see in this section. Images, the Docker images right now, we can keep it on one side. Deployment basically means that you are deploying it. And let's just click on, so what is this? So you will be doing this. So once you are in machine learning service, you have to click on download configuration. What does this download configuration holds? I have given this step that you can click on the configuration file from the top, and yeah, sorry, it's over here. So you can download the configuration file. What is this configuration file contains? Some information about your machine learning service, like which subscription are you using, what's your resource group, and what's the name of your service. All those basic information. We just need it. Just download it, and you will click on launch option as such. So this is the interface or the new interface of Azure Machine Learning opening up. It's the same thing which we have in this tab. Slightly more options are there, and in future this interface will be, which is what will be persisted for further use. Let me just show it around to you. You don't have to be an expert right now to be able to run it. In the Jupyter notebook, we actually are doing it from the notebook. So when you run something over there, something will happen over here, right? So I have notebook. Automated ML just means that if I don't know which algorithms I want to run, if I'm not sure about which hyperparameters I want to run, I can do automated machine learning. Just pass the data through it, and it will run that particular thing. So designer is basically where we have visual designer. You can drag and drop. So we are not doing it right now. We are doing it Python, but you can drag and drop and do things as well, right? So if you click on this designer option, you will see more options. Data set is where we are saying we can register a data set. That's what we are talking about over here, that I can register something as a data set, which is more like a tabular or file format data set, not relevant right now. Experiment means what version of my experiments are there, whether when did you run it, and how many runs did you do, which one was completed, which one failed, and so on and so forth. What type of examples were there? So pipelines, models. So pipeline is the entire thing. Model is what I have over here as my you can say trained model. So once you will do this step of registering a trained model, and everything will get your trained model will be saved over there in this model section. I can show one to you. If I click on this model section and just quickly go to the one which I ran in during the lunchtime, artifacts, and you will see the trained models will be there. Whatever you train will be there. So it's a convolutional neural network. Saved weights are there, which will be there. Endpoints, we are not working on endpoints right now, but endpoints basically means that deployment is done. Once you deploy, what is the API endpoint where the API call will go, right? That's what endpoints are. Okay, so let's work with it. So you're gonna create one Azure Machine Learning workspace like that. It will be empty in the starting, right? Then what are we gonna do? There is a thing called as notebooks.azure.com. Let me come out to the landing page as such. So this is notebooks.azure.com. Now, why am I creating a notebooks.azure.com? Why don't I create something directly inside the portal over here in this section? The reason being that most of you will not be having a paid subscription. So I have a paid subscription. I can create maybe you can say 440 GB RAM cluster over there. But when you guys will do the tutorial, you will have maybe a free subscription. If you don't have any company subscription, you'll use your free subscription, right? We'll redeem one free subscription. So we might not be having CPU availability in a free subscription to be able to create big clusters. So we are not creating big clusters. We are trying to save some resources, right? So that's why we are using notebook.azure.com. What is notebook.azure.com? So whichever user by which will log in into the Azure portal, with the same user, you can log in into the notebook.azure.com, right? And over there, create a project. So here you can say, click on project, create a project from here, navigate and check it out. And once you create the project, what you have to do, you can download the notebook. So what I have done, this is my project. I have made it public as such. It's over here. This is a public project. So the link of that project is available in this page. So if I click on it over here, I should be able to click on it. And so it basically opens my project, and you can download the entire project. So once you download the project, we basically need one file, only this file. The others are coming because I just executed the file, but you can avoid them or you can upload them. Nothing's gonna matter as such. So we just need that one file. So once you download the project, you just needs to upload that one Python notebook or Jupyter notebook inside your project. So just make a project, upload it. So it says stopped right now. So I'm just saying, please run it on a free compute. So my Jupyter notebook is running right now. Our Jupyter server is getting created. And this is my Jupyter notebook in cloud. So this is very similar to how Colab also works, right? This is also free. And now I am just clicking on the notebook. So you will also open the notebook, and let's now talk about how will you make a CNN with Azure, on Azure as such. So let's just wait for the notebook to open. Right. Now, some basic standard things, importing Azure ML SDK and so on and so forth. Experiment basically means that when we which experiment, CNN, or you are doing something else, and so on and so forth. Keras. So we are creating an experiment called as Keras MNIST, right? And so that's first part of it. Now, second part is, you remember, this is where we were talking about that we have to connect to the Azure Machine Learning Workspace. So this purple part. So that's what we are doing in this section. We are saying that, okay, I want to connect to my Azure Machine Learning Workspace so I can submit my job over there and I can train a convolutional neural network in that location, right? So for doing that, I have to connect to it. So we are dropping a thing called as workspace.configuration file. You remember we just talked about there is a configuration file we have to download from AML workspace. So if I go one step back, you really need to upload. So whenever you create the AML instance, you will go and you can click on sections such as upload and upload the configuration file which you downloaded from the previous step over there. So whatever file you have, your file, so you will see that there is a sample file from my sample project, but this will not work for your use case because mine is already is connected to my environment, my subscription, my resource group. You won't be able to work with it. It connects with my solution as such, right? So you have to replace this with your configuration file. What is the usefulness of configuration file? It basically connects, right? Now my Jupyter notebook, which is running maybe locally, maybe anywhere else, in any editor, will connect to Azure Machine Learning Workspace. We have to do some sort of interactive authentication. What's the meaning of interactive authentication? So understand it like this. If there's a human being, they are doing an interactive authentication, they are present over there, and the person will be humanly giving the values. So when you will do this, we are doing interactive authentication, you will click on this link and pass the code, which you will get when you will execute that particular cell code. It is for authentication purpose, right? And once you click on that, you pass the code on this link, you finally will be able to connect your Jupyter notebook to Azure Machine Learning Workspace over here, right? So if I just quickly show it to you, so then we are going to create a new experiment. So this is a new experiment over here we are creating, and this experiment is having it's called as Keras MNIST. So we are using MNIST dataset, and MNIST dataset is having digits are there basically. Let me just quickly see if I can pull one image as such. I am very positive you all know what MNIST dataset is. However, this is what MNIST dataset looks like, right? Let me just open Wikipedia. So 60,000 images are there, 10,000 are for 70,000 are there totally as such, and digit recognition is going on 0 to 9, and we are using a CNN to work with this data, right? So we will have MNIST dataset we are creating a CNN on top of. So that's one of the steps where MNIST dataset will be downloaded, right? So the name of the experiment is also Keras MNIST. So what I'm doing over here, we are saying, okay, Azure Machine Learning, please give me a compute cluster. So this is where we are saying, I want a compute cluster, and I want maximum can be a 4-node cluster. So if there is more load, 4 nodes will be created for you. If there is not more load, we will simply go for like scale it down to 0 cluster. What type of VM? It's not relevant right now. This is called a standard D2V2. Basically, it is a virtual server where the training job will be submitted, and let me just quickly show that again. So this is the cluster I'm creating in this scenario, right? So a 4-node cluster will be created for you, and this is where the training job will be submitted afterwards. So whatever code you write, that job will be submitted in this cluster over there. So we are just making that cluster in this point in time. And we are saying that if cluster already exists, don't create it, and so on and so forth. So found the compute cluster, just use it, CPU cluster. Okay, now notice this. So this is where we are making a train.py file. What is this train.py file? The file is basically where the CNN code exists, and this CNN is what we will deploy afterwards over there. We will say submit the job, and it will run in that location. Give me a second. Let me close the PPT so I can be a little more comfortable with the screen. And right. So give me a second. And okay, I just basically lost the chat window. That's what I was searching for. Check this out. So what are we doing over here? Train.py file. So the train.py file is basically where we are making that CNN structure. And what is the CNN structure which we are creating? I will show you one quick picture which I took. So this is a structure which we are creating of CNN. We basically are having then there is an input image 28 by 28. There is a convolutional you can say layer is there, CNN layer is there, where convolutions are happening. 8 filters we are using at the same time, 8 filters. And 26 by 26 is the feature map size which will be created. And 26 by 26 is actually the size of that The feature map is actually 8 as such. So this is the output of the CNN layer. So on the input layer, when you do the convolution, this is the CNN layer which will be creating, and then we are doing some pooling on top of it. So on top of the pooling, we will be getting some 13 by 13 into 8 as such, and this is the pooling output. So we don't have many layers. We just have one CNN, one pooling layer, and a softmax layer. We will have 10 outputs. Why 10 outputs? Because it's MNIST data set. There are 10 classes, and we will get the output as such. So this is the diagram what we are trying to create over here. And so this is where so the file is not running right now. The file is, we are just writing in a local location. We are saying, okay, the location is called as train.py. It's in the local script folder, and the script folder will be in notebooks.azure.com, will be there in the same location. So you can create that, and this is where we have that particular file. It's not running right now. We'll submit it afterwards. So then we add sequential layer. What is sequential layer, and so on and so forth. Check this out. So we get the data first. The data is available, is by default available in a package called as MNIST. So we are using it for because it's anyways available, so it's easy to use from there. We can also have a data into any other location in cloud platform, and we can read from any of these locations and any other cloud as well. If you have a HTTPS location, HTTP location, you can read the data from there as well directly. So then we are doing some normalization on the layer as such on this data. So it's basically we are doing a normalization, and the values will be between a range negative 0.5 to positive 0.5. Why we are doing it? Because it makes it smaller. It makes it more easier to train with, and it will be very fast to train on. Then we are doing some reshaping. So we are adding one more dimension after that. This is basically Keras required an extra dimension to be added. So we are adding one more dimension as such. Number of filters we are using is it will be learning 8 filters. Filter size is 3 cross 3, right? And pool size will be 2 as such. So 2 cross 2 will be the pooling size. So how do we stack the layers, right? So this is basically how we are saying, okay, create a sequential model. So sequential model is what we are having as a linear model, where one layer will be there followed by one more layer, and so on and so forth. There is nothing customized as such. We will have a simple layer by layer structure, something looking like that. So we are saying convolutional 2D, number of filters 8, filter size 3, input shape you have to provide. So that's the input shape you always have to provide in the first layer. So you will provide it like this. Pool size will be equal to pool size over here too. Flatten is used basically to pass my, you can say, from the pooling layer to the softmax layer. I just want to pass my data. So we are adding a layer called as, let's say over there, flatten, and just flatten it out, like pass the values. And the activation function we are using as softmax. Softmax will give us the probability output in 10 classes. The digits are 0 to 9, so we have 10 classes over there. And here we are doing a model.compile. Adam optimizer is used. What is Adam optimizer? If you invest 2-3 minutes of your time and check out a couple of links which I have given, it will give you a very good initial idea of how Adam optimizer works in these links as such. Right, it is something which takes time to get a hit on, but some very interesting links are there over there which you can work with. Okay, what is categorical cross entropy? So if it is multi-class classification, basically more than 2 classes, 2 or more than classes, we use cross entropy categorical type. And for this, we need a hot encoding to be done. So we are doing a hot encoding on the data as such. And metrics is accuracy and model.fit. So this is where we are saying, okay, train my models and just pass the values back, and save the output back into this location, and so on and so forth. So what basically is happening, we are creating this train.py file. It will create a small convolutional neural network with a couple of layers. We will have a convolution layer, we will have followed by a pooling layer, and then a softmax layer. 3 layers will be there. And now we are saying, okay, submit, and there's a new concept will be there called as estimator. So what's the estimator? Estimator is basically, if you imagine that from your point of view, you are sitting over here, that's a data scientist. Now they might be using Keras, they might be using TensorFlow, they might be using R or Python, and these are various type of technologies. One is a Spark cluster, one more might be a Windows machine, one might be a Linux machine, and so on and so forth. So various type of technologies might be there. So you need a sort of umbrella term, or you need a sort of estimator which can convert your code into various uh, compute locations where you can just trigger your code and it will run on various locations like that. So here we have a estimator called as TensorFlow estimator, which is basically saying that I have a TensorFlow is the backend of Keras right now, and the training file is over here, which we have saved in the local folder. There is a compute cluster already created on the top, and in the remote cluster, please install Keras, NumPy, and MList. So the remote cluster means over here. So before the job will be submitted and run in these remote clusters, we will install the environment over there. So one Docker container will be created by default for you in these clusters, and inside that, the packages will be corner dependencies of pip packages will be installed, Keras, NumPy, and MList, and basically then we say, okay, run it. So this is where the job will be submitted on the cluster to run, and then you will be able to see it takes a couple of minutes for it to. So what do? They basically create a Docker container for you first, and then they install everything you require inside the Docker container, and it takes a couple of minutes, maybe 5 minutes. You may have to wait on this particular step before your iteration starts, right? And then you will see that your iterations are starting, and we are doing 12 epochs as such. So 12 iterations on the data we are doing, and you will be able to see that we will be so these iterations will be going on, and you will see the log output of that. So let me just quickly go down, and by the end you will be able to achieve around 96 or 97% accuracy as such, using just basically just two layers, one unit of CNN and one pooling layer. 97% accuracy will be we will start getting that on MNIST dataset using a very simple convolutional neural network like that, right? So all these outputs will be there, and finally we are doing a register my model. Register my model basically means that now my model is trained. Can I deploy this? So before we deploy, we say register. As soon as you register, your model will be there in the model registry. So this is a model registry, and the versions which you are having, you can click on the artifact as such, and you will see a folder called as model, and your model will be there saved inside that, right? Then I'm just downloading the model back again. This is where we are downloading it back again. So this is the step we were saying that, okay, we can also download the model back again, this blue line, and we want to do some local testing. So we just reconstruct the CNN one more time, the exact same structure, and the weights are already there. We load the weights, and we basically do the same normalization and so on and so forth. And we are getting this is where we are trying the labels. We are doing a scoring, and you can change how much batch size you are giving, but your input variables and what is the ground truth as such. So your predictions and what it was supposed to be there. So it's a small batch of 5 digits, so it's doing well. You try it in the tutorial further. Right, so let's start doing it, and if you get stuck somewhere, I'll help you in real time as such. So what is the first step? How are we going to start with it? So basically, we need an Azure subscription. That's the first biggest problem, right? Because if you're doing something on an Azure platform, on a cloud platform, we need a subscription to do that. Now, subscription is something, there's a thing called as a free Azure subscription available. So I can click on this link over here, and it will take me to this free Azure subscription page. I can click on it, and I just have to fill up some information. Now, the scary part. When you will do the sign up for the free Azure subscription, yes, they will ask you for a credit card information. They don't want to take your money. What they just want to do is that this person is a valid person. So they will just verify that you are a human being and you are doing a fair creation of a subscription by taking your credit card information. They don't take any money from it, right? So money in the sense they will just detect, I think, 2 INR, and then they will revert it back just for the verification purpose. Now, what will happen if I create a Azure machine learning service, or I create 10 type of services in Azure and I forget to delete that? Will I be charged on my credit card? No. By default, after 30 days, or even if you burn the $200 which are given in the free account, if you burn that, your account will be deactivated automatically. Nothing is going to be charged in your subscription. So do that. Then so how do I sign up over there? So when you have to sign up for Azure, you please use your personal email IDs, outlook.com, gmail.com, and so on and so forth. Don't use anything like a Office 365 or your Office accounts. Don't use that. Personal things. And make a Azure subscription. The steps are there. You can follow steps here. That's how you create an Outlook account. Some FAQs are there for you to read. And create a machine learning service. The steps are here. Follow it. Make a machine learning service in East, West, Southeast Asia, in one location. Sign up for Azure notebooks. Download the notebook from this location, upload in your, and start running it, right? Step by step. So by the end of it, we'll have one CNN structure on MNIST data set, like that. So this is the article on Medium. Let's start. And if you get stuck, let me know. I'll show you exactly what we are doing. And any question which comes to mind, just put in the chat window. Let me go through that. Okay. If my code files are done by Anaconda, can I get them to Azure? Yes. Yes. By default, what? So this is a Jupyter notebook. It's the same what you can have on premise as well. Exactly same versions of Python, Anaconda, everything is pre-installed. Totally portable. You just need to add couple of Azure-oriented SDK. You see this? This is Azure-oriented SDKs. Once they are added, it's totally portable. Okay, so try it out. Let me know if you get stuck on any step as such. Make an account, make a free account. Basically, it's a 2 minutes of process. Once you have the account ready, make Azure Machine Learning Service, and let's create a simple CNN structure over there, architecture, and run it. It will train on the remote cluster, and you will be able to work with it. So this diagram which I have over here, I'll just give this diagram to you. I'll put in the basically in the chat for any future reference. So the diagram is there in the chart window, and it will be given to you very soon. I am just putting in the chat window as such. Start with it and let me know how can I help you with it. And I will be joining the other stream in 2 minutes, right? So in 2 minutes, I'll just go to the other stream as such, and I'll see you there. But create your account first. And if any instruction is not clear, so I just created this tutorial in a very short time as such. So if any instruction is not clear, just let me know, I'll modify it, right? How to calculate number of parameters in each layer. Now, that depends on many things are there. I can give you, let me just find a couple of formulas for you. Basically, it depends on what is the size of my filter. What is the input image, first of all? What is my input image? Secondly, what is the size of my filter? Third, what is the padding which I'm using? Fourth, the stride which we are using. Fifth, whether what type of pooling are we using, max pool, average pool, or and the pooling filter is having what size. So those are the factors on which the layers depend on. So you need to calculate them first, and making the structure in Keras is pretty straightforward. Okay, so I guess I will join the next stream link in a minute or two. So, okay, what is applied deep learning? You see this Medium article is there. If you click on the this applied deep learning, it's basically a place where I write these it's a publication on Medium. I write these articles over there. So if you're interested in reinforcement learning, you can click on this one. If you're interested in creating a stock trading system with Azure Machine Learning, right? Click on this one. Basically, these are cloud oriented, so I'm not sure if you're interested in these. You can check it further. But data for machine learning, CNN part 1, never made part 2, I think, and so on and so forth. There should be a little more as well. Okay. So I'm just joining the third stream now. I'm dropping off from here. I'm joining the next stream, right? So I am just stopping the screen share, and I'm dropping, and I'll join the next stream in a minute.